Hello, everybody. This is Bert Dixon here presenting on section 2.3 in Math 40. So on page 75 in your text, there are some examples of other types of graphs that we sometimes use to display data. The first one is an example of a bar graph. Bar graphs can be horizontal or vertical, so they are very similar to histograms. They can be horizontal or vertical. And then in B, we have a Pareto chart, which is a Pareto chart is really just a special type of bar graph. In this text, the distinction they make with the Pareto chart is that the frequencies are displayed from largest to smallest, and that's just another technique we can use to show big differences from one category to another. There are actually a lot more sophisticated Pareto charts that you could encounter in a upper level statistics course. But for the purposes of this course, we'll just say a Pareto chart is a bar graph where we have arranged the bars from tallest to shortest or longest to shortest. And then in graph C, we have a time series graph where we have time on the horizontal axis. And then in this example, it's temperature, but it could represent any quantity on the vertical axis. But the idea is that you plot the points over time and connect the points to create a time series graph. And then I'm sure you've all seen pie graphs before. In a pie graph, the proportion of the circle that is shaded is proportional to the percentage of the whole. And so there's a little bit of geometry involved to figure out how many degrees should I be shading in the for each sector of the circle to correspond to the correct number of degrees. And so we'll talk about that in one of the examples a little bit later. And then finally, we have a dot plot. A dot plot is, again, very similar to a bar graph where the heights of each bar represent a frequency. So at 6, for example, 6 on the horizontal axis, the frequency was 3. So that's represented by 3 dots. And then at 7, the frequency was 4. And so the vertical stacking of the dots is very similar to the heights of bars. So this could very easily be represented in a bar graph just by simply making these bars instead of stacking dots. So not too much difference between a bar graph and a dot plot. The nice thing about a dot plot is you can kind of create it as you go because you can just keep adding dots as you get to the next data point. Whereas with a bar graph, you kind of need to know ahead of time before you make the bars how tall your bar is going to be. Otherwise, they're very similar. So I'll work through a few examples with you. It's up to you whether you want to copy down these examples. The only thing you're really required to show in terms of writing is on the student notes portion of this. So if you have not yet printed the student notes for chapter 2, you can do that by accessing the student notes for chapter 2 in Canvas, or let's see, I've also got those here on the Math 40 instructional, the assignment grid. And so here, for example, if you print that document, the student notes for chapter 2, that has everything you'll need for the entire chapter, which you've already done. You should have already done the student notes portion of 2.1 and 2.2, and today we're finishing up by doing 2.3. Okay, so in example 1, we are creating a bar graph to display this data of the commute time for each of these cities. And so on the horizontal axis, I'm going to put the city. And on the vertical axis, I'm going to put the number of hours. And title the graph commute time. And so Boston, let's see, if we look at the range of values, the lowest I see is 52 and the highest I see is 82. And so I'm just going to make each box 10. So 10, 20, 30, 40, 50, 60, 70, 80, and 90. And so my first box is going to be Atlanta, so it's going to go up to a height of 52. So 52 would be right about there. And I could write the word Atlanta down here. Or it might look nicer if I just, since the bars are all going to be tall enough, I can just write it right inside. How you choose to label those bars is up to you. Boston is 64. Chicago is 61. New York, 74. And then finally, Washington, D.C., which is at 82. Okay, and so that's all you need to do to create a bar graph. Now notice that this could very easily be converted into a Pareto chart, a simple Pareto chart where we just arrange the data from largest to smallest. So for example, I could create a new table here. Where here we would have, putting them in order, the biggest one is Washington, D.C., and that is 82. And then New York is 74, and Boston is 64. So all I'm doing is rearranging these in order from largest to smallest now. Chicago is 61, and Atlanta is 52. And so same idea as what we did before, except it's going to start with Washington, and I'll go ahead and butt them up next to each other. So Washington is 82, and then New York is 74, and then Boston is 64, and Chicago is 61, and Atlanta 52. And then again, I could go ahead and label them. And again, the advantage of a Pareto chart is that when we put them in order, we really, the tallest one just jumps out at us right away, and the shortest one jumps out at us right away. So it's a lot easier to see rather than looking at a graph like this where you have to kind of look at all the different bars and decide, okay, which one's highest, which one's tallest. The ordering doesn't really matter, so why not put them in order like in the Pareto chart so we can see right away which one is the tallest and see how much it falls to the lowest very easily. So visually, it's just a little bit easier to demonstrate what our data is doing. Okay, so then in the next example, we're going to create a series time graph for just for the United States, so we can kind of ignore these columns. And so we need, let's see, our y values range from we'll call that 5.7, that's 5.8, 5.8, 5.7, 5.8, 5.7, and 5.3. And so they're all in the fives. And so on my graph, I'm going to have a broken vertical axis. So I put the jagged line there to indicate this graph is not starting at 0, or there's a break in between 0 and the number that I'm starting to plot. In fact, I'll just go ahead and do it like this instead. And we'll call this 5, and then this will be 5.1, 5.2, 5.3, 5.4, 5, 6, 7, 8. So this one is 5.8. And so this vertical axis represents the emissions in millions. And emissions of CO2 in millions. Okay, and so then this needs to be a time sequence where we start at, let's see, our data starts in 2003, so we'll say this is 2003, 4, 5, 6, 7, 8. I'm just labeling a few of them. And so each horizontal bar represents 1 year. And so 2003, we see that it is at 5.7. So we would have a dot there. 2004 is 5.8. 2005 is 5.8. 2006 is 5.7. 2007 is 5.8. 2008. Oh, let's see, did I skip 2006? I think I missed one. So I have 2003, 4. Oh, I see what I did. I just mislabeled the axes. So 2003, 4, 2005 is this one, 2007, and 2009. So 2007 is 5.8, 2008 is 5.7, and 2009 is 5.3. And so then if we just connect these with lines from point to point, that creates what we call a time series graph. In example 3, we'll create a pie chart, and we'll just do it kind of roughly here by hand, but then I'll show you some tools that you can use to create more accurate angles than the estimating that I'm going to be doing when I'm doing it here by hand. So here we have data on the favorite types of movies from looks like 20 people that were surveyed. So the total is 20. If you add up 4 plus 5 plus 6 plus 1 plus 4, there were 20 people surveyed. And this data tells us how many people prefer comedy, action, romance, drama, or sci-fi. And so first we need to convert these into percents and then into degrees, so we know how many degrees it'll take up on the pie chart. So for comedy, I'm going to do comedy is 4, and I always divide by the total 20. 4 divided by 20 is 20%, and then 20% we do 0.2 times 360 degrees, because a whole circle is 360 degrees. That turns out to be 72 degrees. So on our pie chart, the sector that represents comedy, if you can kind of picture what a 90-degree angle would look like, 72 is going to be a little bit less than that, so that would be approximately a 72-degree angle. I could use a protractor if I was drawing this by hand to get an accurate angle, and like I said, I'll also show you some technology that you can use to get these angles a little bit more accurate. So this one represents comedy, and it is 20% of the data. Okay, and then we'll go to action. Action is 5 out of 20. 5 out of 20 is 0.25, which is 25%. So if we take 25% of 360, we get a 90-degree angle. And so I just need to create a 90-degree angle. It doesn't matter which way I go, I'll go this way. So I want that to be a perfect 90-degree angle. And that represents 25% or 1/4 of the circle, and we'll label that as action. And then romance represents, or there's 6 out of 20 people, and so that is 0.30 or 30%. So 30% of 360. 0.30 times 360 is 108 degrees. And so going this way, 108 degrees, it's going to be a little bit more than 90. So that would be probably a little more, maybe about like that. That is 108 degrees, and that represents 30% of the circle, and that is romance. Let's see, I might have to adjust that. I think that is a little too big. So we'll just go just a little bit past 90. Okay, and then we have drama. Drama is going to be a pretty small slice because it's only 1 out of 20. 1 out of 20 is 0.05 or 5%. And 0.05 times 360 is only 18 degrees. So that's going to be a pretty small slice. So this is 18 degrees, and that represents 5%, and that is drama. And then the last one is sci-fi, and that is 5 out of 20, which is 20%. And then 0.2 times 360 is 72. And so this is a 72-degree angle that represents 20%, and that is sci-fi. And so you can, of course, make your pie chart look nice and neat with shading in different colors. For example, I could say I'm going to shade this in blue and so on. So you can dress it up however you choose. Now, if you wanted to get more accurate angles there, these are all these numbers are all correct and exact, but when I drew it, I was just estimating about how big 72 degrees was. So what I'm going to do is I'm going to go to my browser, and I'm going to go to Desmos.com/geometry. I'm and show you how you could create this. So this way you could print it easily. So I'm just going to make a circle. And I'm going to put, since I had 5 categories, I'm going to put 5 dots around the circle. There was already one there from when I created the circle. So there's 3, 4, 5. And then I'm going to measure the angles. And so if I measure the angle going here, 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 and then here, 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 you always the vertex is always in the middle. So to measure an angle, you just always click on 3 points. So I'm going to click this one, this one, this one, and it measures the angle. And then the last angle here, I would click this point, the vertex, and that point, and it measures that angle. I should put some segments connecting these. That will make it look a little bit nicer and easier to see what's going on. Now, I just randomly placed those points, but you'll see in just a minute I'm going to move them to get the angles that we had in this problem. So if we go back and look at the answers we got, we had 72, 90, 108, 18, and 72. And so I'm going to adjust this one so that it's 72. So just by dragging, whoops, sorry, I didn't mean to do that. I'll get rid of that point. And so if I click on the selection tool, I can now drag this point and see how the angle changes when I move it. So I changed that to be a 72 degrees. Then the next one was 90 degrees. And then the next one was 108 degrees. And then this one was 18 degrees. And then the last one was 72 degrees. So now I've got the correct angle measurements by using this technology tool. Okay, another thing you can do when you're creating these bar graphs and pie graphs and things, you can check what you did by hand with a quick Math is Fun app. So if I wanted to put any of the data in this table, it'll create the bar graphs and pie graphs and whatnot for me. So if I want to do a pie chart, for example, all I have to do is put in the values from my table. For comedy, it was 4. For action, it was 5. For romance, it was 6. For drama, it was 1. And for sci-fi, it was 4. And then the labels, comedy, action, romance, and sci-fi. Okay, and then it creates a nice graph for me. I can have it put in the percents, and you see those percents are exactly the same as what we got when we did it by hand. You can even have it put in the numbers and so on. Okay, so we could compare that to what we got when we did this. So if I move that over, we might be able to look at both at the same time. And see how our graphs compare. And that looks really similar. Okay, so at this point, you should be ready to do the rest of the Chapter 2 packet. So that starts at this page that has the vocab words at the top. You should be able to do the rest of the Chapter 2 student notes now, which ends down here. So there may be some other, if you come across a question that you feel like I didn't cover in today's lesson, please go to your textbook. There's some terms here. We didn't talk about all of these terms today, so you may need to go to your textbook. You can use the glossary or the chapter reading for section 2.3. They could come from other parts of the chapter as well, but we're all done with chapter 2 now, so you should have, from all of the readings from those chapters, from those sections, you should be able to complete the rest of the student note template and then turn pics of that in Canvas. Have a great day, everybody.